So just a quick overview of the webinar, what we will be looking into. First thing, we'll just quickly introduce the SolidWorks Electrical and go through the couple of what it can and what it cannot do, and what is so basically just a quick overview of SolidWorks Electrical in general, and where does it fit between all the SolidWorks other products. Then we'll do the short demo of SolidWorks Electrical, 2D and 3D. After that, we'll look into what are the products on offer from SolidWorks in regards to SolidWorks Electrical. Then we'll see some of the configurations of SolidWorks Electrical installation of different products. And after that, we'll have a question and answer section. If you got any question, you can just just type it in onto the question or into the chat section, and then I'll try my best to answer all the question in the webinar. And if I can't get to any question during the webinar, I'll get back to you in personal and respond all these questions. All right, next thing. So where does it fit into SolidWorks portfolio? So SolidWorks been out in industry for a very long time, and they've got products. Sorry for that noise. They've got products from for different types of applications, for mechanical design, for the simulation, for EPDM, which is the product data management, and also or document management software tool, Composer, SolidWorks Composer as well. And now they've got a fifth product line, which is SolidWorks Electrical 2D and 3D. So we'll look into detail what is it. So what is SolidWorks Electrical? Before we get in too much detail what is SolidWorks Electrical, I like to set some expectations so you know what you can expect from the software and what it can do and what it cannot do. So the next slide covers what it cannot do. For example, circuit simulation. It's not a simulation software, so you cannot do or simulate the circuit that you design in SolidWorks Electrical. It does have a few validation tools, so it validates your design as you're building it, but it cannot simulate the circuit. PCB and PCA. So your PCB and PCA layout and design are not possible in SolidWorks Electrical as well. So if you may use, for example, an Altium or some other softwares to do a PCB design. PLC programming, again, PLC programming, you cannot use SolidWorks Electrical for PLC programming. You can draw PLC drawings in there, but it's not a programming tool, such as, for example, Allen Bradley or Schneider PLCs. They come with their own software or programming tools, and that's what you should be, or that's what the manufacturers prefer to use. So let's just clear these things are not cannot be done in SolidWorks Electrical, and let's go ahead what is SolidWorks Electrical? It is a complementary to software for these purposes. I mean, you can use, once you've already designed the circuit, PCB for example, you can use that circuit board or PCA, which is printed circuit assembly, into SolidWorks as in 3D file, and then you can also create connection points and do a few other things. So you can use as a complementary product or a software to the above applications. So what it is for, it is mainly for electrical system design. So for example, if you're doing any design at a system level, not at the PCB level, then that's SolidWorks Electrical it's made for, and it's got very smart. So if you're doing anything to do with electrical or electromechanical, which is or mechatronics type system, then SolidWorks Electrical is a tool that you should be looking into, and it's worth looking into. What you can do, for example, you can do single line block diagrams, layout drawings, multi-line schematics of your power and electrical schematics, your control schematics, PLC drawings. You can also do hydraulic and pneumatic designs in there, and also the wire harness design. So quite a few. There's many applications that you can do in SolidWorks Electrical. So SolidWorks Electrical, let's have a look what it is. Electrical schematic. SolidWorks Electrical is divided into two different components, electrical 2D and 3D. So on 2D side, Let's have a look. SolidWorks Electrical. What you can do in Electrical 2D, you can do single line block diagrams, multi-line schematics, your general layout drawings of an enclosure or a panel, or that's your control layout drawings can be done in there as well, and also hydraulics and pneumatic drawings, as you can see on the screen. Then you've got another component which is also separate from SolidWorks Electrical 2D. So what you can do in there, you can create your wire harnessing, route cables, route wires, and route of harness is possible in SolidWorks Electrical. You can also do ribbon cables, but you cannot do flex cables in there. So ribbon cables, again, wire harnessing and cable routing, wire routing are all possible, are one of the applications in SolidWorks Electrical 3D. And how it works, there's a unique bi-directional link between Electrical 2D and Electrical 3D, which allows multi-users to work in a live bi-directional environment, which means mechanical guys can work on the 3D design of the project, and electrical guys simultaneously can work, or at the same time or in parallel, work on the same project on the electrical side. So it's a live bi-directional link or environment between Electrical 2D and 3D. So SolidWorks Electrical content libraries, for example, SolidWorks Electrical contains a huge amount of a big database of manufacturer parts, symbols, components, cables, and different wire types, and also some 3D parts and title blocks. When I say 500,000 parts or symbols and few different things, it contains manufacture of nearly 500,000 parts from different manufacturers of all the electrical components. It may not be suitable for every single company out there, as you may have some customized parts, you may have your own parts, but these libraries are very easy to customize and very easy to import your own library of parts that you may have in there. And again, and same applies on the electrical symbols. So it's got 4 standards: ANSI, North American standard. So if you're working in that standard within SolidWorks Electrical, the symbols you will see, electrical symbols, will be from ANSI environment. Then if you're working, the second standard is IEC, which is the most relevant or similar to Australia and New Zealand standard. Then you'll get to see only IEC symbols in there, and same applies to other 2 standards, which is JIS, that's a Japanese standard, and CB, that's your Chinese standard. So if you're working in any of those standards, you get to see the symbols from those standards. But you can always view the symbols from other standards if you wish to. So, and we call it a starter set, so because since it's not going to be suitable for every single customer, you may customize it or seek our help in customization, as we've got a full onboard programmers to help you with that as well. SolidWorks Electrical libraries, again, as I've already mentioned, very easy to customize, modify, or do anything. We'll cover that bit in a demo. Okay, now so you may have seen so far or realized where it's leading. It's combining 2 different principles of engineering together. I mean, you're still working in electrical work in their own environment, and mechanical guys work in their own environment, but at the top level it's a collaborative environment. So the feedback and the work from both sides of the engineers, electrical and mechanical engineers, gets done into the same software and using the same tools. So it's very easy to manage from the document side and also from the project side of things. So it's all about unifying electrical and mechanical design. You still electrical guys still work in the 2D environment, and 3D mechanical guys still work in the 3D environment, but it's a collaborative environment. All right, so next one, SolidWorks Electrical demo. Demo itself I've divided into 4 different sections. So planning and layout from 2D and 3D side of things. Design and schematic. Here we'll create some of the schematics and see how it is, how our schematics are done in SolidWorks Electrical, and show some of the smart tools available within SolidWorks Electrical, and automated tools available in SolidWorks Electrical. 3D routing and bill of material. Here we will look into the 3D side, how the wiring and the cables gets routed, and how it calculates the accurate length of the wire or the cable, whatever you route, and includes those lengths into the bill of material that we will create at the end. Data management, here I'll cover how the revisioning gets done in SolidWorks Electrical, and also we'll look into how it works with EPDM. There's a built-in link that to EPDM or different PDMs, so you can configure to work with your own PDM if you've got any. So let's have a look. SolidWorks Electrical. So let me just get out of this screen and open SolidWorks. So what we will aim to do in this demo, I'll show you, zoom into this. We will aim, if you can see this control panel or the enclosure on my screen, we aim to create a same enclosure in a different drawing and create the wires and route the wires similar to the ones you can see in the enclosure on your screen, and create the schematics that drives the route, that drives the electrical routing in 3D environment. Alright, so if I show you on the right hand side, for example, of this software, you can see where my cursor is. That's your project document tree, and that's where you can see all your, for example, a cover page. So that's your cover page. You can also view all your 2D drawings if you need to in your 3D environment. So all these drawings are can be seen in 3D, all your 2D drawings, but they're not editable. Of course, you don't want your mechanical engineers to do anything on the electrical circuits. And other cool features, you can also attach all the reference documents to your project. For example, if you got some components from Schneider or circuit breakers, you can attach the data sheets in there quite easily. And not only PDF, any document that you may wish to attach, you can attach into the reference documents. Alright, so and all these are your 3D files. So let's just open 3D file and we start doing our planning from the mechanical side, but we'll do it from both so you see what are the differences. So let's just zoom in to my main electrical enclosure, and that's my main electrical enclosure. So what we will do, we'll create a circuit behind this main electrical enclosure and drive and that will drive the routing of this enclosure. Alright, so let's just open SolidWorks Electrical and see. And as I already mentioned, Electrical 2D is a standalone software. So you can see on my screen, the top one which says webinar is in red color, all the others are in black. So red means this is already open somewhere else, and it's telling me how many users connected to it. 1, if you can see on my screen. So let's just double click on it. It's a multi-user collaborative environment, so many users can work on the same project without any problem. So you can see, you get to see the exact same document tree in 2D environment. So if I just expand, all your reference documents and everything are all accessible from the 2D environment as well. So let's open our single line drawing and we'll start from the single line drawing. And also, so that's our single line planning tool, you may call. And if I just change my view back to 3D, so that we're back into 3D environment, and change my view to motor. So as a mechanical guy, you don't know too much, you don't worry about anything from the electrical circuit or design work. You just do your mechanical design and you choose, for example, where my cursor is the best available place for the motor. So what you'll do, you will simply insert that motor in there and no problem. So notice that in this location, the last inserted motor is M4. So, and when we'll create something new within 2D environment, this will be updated. So let's just go back, and where it says add motor in 2D environment, we'll insert a motor by clicking on insert symbol, and it always gives you the last use symbol. If the motor wasn't the last use symbol, I would have to click on other symbol, and that's my symbols library in there. So, but I need to use motor, so I can just drop motor here. It already knows the next available number for the motor is M5. So because the 4 motors are already in the system, so next available number in the cycle is M5. I can choose the right location for my motor where I want to insert this motor. So hit OK, and now I've got this motor. So if I go back into my 3D environment, you can see how there's a new motor called M5 inserted in my project tree. So then the mechanical guys know, okay, they need to insert a new motor in here. If this motor wasn't here, or if this motor on my screen wasn't existed in 3D, then he would knew that, okay, he needs to exist M5 in location L4. Alright, let's connect this motor to my terminal strip X1, which is right here. And if I just zoom out a bit and show you the overview or the whole drawing, you can see what we're trying to achieve here in what we will try to achieve or create in multi-line schematic environment. We will connect this motor or create a circuit for this motor to be connected to terminal strip X1, and then through terminals X1 we will connect that to contactor K4, circuit breaker Q4, and then we'll also power up this PLC where my cursor is through that transformer T1 and circuit breaker Q6. So let's just open my multi-line schematic. So that's my multi-line schematic. What I need to do in this environment or in my multi-line drawing, I need to replicate this drawing. So easiest way is simply you can select the one similar circuit that you need to reuse, Control C and Control V, and paste it wherever you need to paste it. Alright, but we'll create it from the scratch, and I'll show you how you can do it from scratch. So I'll just click on draw multiple wires. You can draw multiple wires at a time, and this, if I click on this button here where my cursor is, will take me to the wire style selector, and these are the libraries of wire style that comes as a standard with the software. But you can create your own wire styles based on each project that you are working on. So let's just close this and we'll start draw this. Alright, so I don't need neutral wire at this stage. All I need is just my 3 phases and a protection wire. So I'll start, and you can notice this black line, diagonal line, indicating the width of those 4 wires that I am going to draw on my drawing. So there you go. So I can draw and just leave it here. And if I hit the space bar, there are a few shortcuts. It inverts the phase of the wire, for example. And if I just hit F8, which is the auto button, I can take all these wires to one location and then draw from here. So these are the few tools or shortcuts available. Now I've got these lines just to show you that these lines are not just the lines, they're actually smart lines. And what I mean by smart lines, if you notice, for example, this highlighted line is one line at the moment. So if I just copy this green line or my protection wire and drop it onto this brown line, all of a sudden it created this connection node and also split that line into 2 different separate lines. So, and again, if I do the same thing with the top green line, it'll split that line into 2 different lines as well. Okay. Now what I'll do, I'll simply drag and drop this line back onto the top line, and all of a sudden this line becomes one line, and so this line becomes one line as well, and not 2 lines anymore. So you're not doing a lot of commands such as cut, trim, and few other commands that you may use. And for example, if you need to move the circuit breaker within lines, you can move it here, and it keeps its spacing between the lines. For example, if you want to move it here, it keeps its spacing within the lines. If you want to move away from the lines or from these lines, you can move away, and these lines are recreated automatically. And if I simply just take it back in there and drop it in the lines, it creates a space for itself between those lines. Alright, let's insert a symbol for my 3-pole circuit breaker. So there's multiple ways of doing it. This time I'll click on the shortcut and hit search and type 3-pole. So all my 3-pole symbols come on the screen. So I'll just double click on it, and again, and another smart feature, if you take these lines, symbols from the library to the vertical lines, they change the orientation and become automatically to go and to be able to fit on vertical lines. You bring them to horizontal lines, they change it changes the orientation itself automatically. All right. Now I'll just again do a cross-reference and make sure that it is Q4, because that's what I wanted to use, or that's what I've chose Q4 for my circuit breaker, motor circuit breaker in single line drawing. So as soon as I put 4 in there and hit assign button, it picks up all the details from single line drawing, including all the manufacturer part number that I have already chosen in my single line drawing. So hit OK. Now I'll insert my motor, so I'll click this button and click on other symbol, go into my motor category and double click on motor. And again, I don't need to drop it right at the end, I can drop it anywhere and it will trim the lines automatically for me. So drop my motor here and make sure this motor is number 5, not 9, because it automatically keeps cycling up to the next available number in your project. So hit associate 5. And at this stage I'll also choose the manufacturer part number. You notice that these symbols are red at the moment, and that's a validation tool. I was talking about it at the beginning of the webinar. These red symbols or icons indicating that whatever the part that I should choose for this symbol must have 4 circuits, otherwise, and the red symbol telling me that it's not red color telling me it's not connected. The symbol I've got on the drawing is not connected to anything. So you'll notice that these red color will turn into green as soon as I'll pick up the right motor. For example, I'll choose Leroy Sommer as my manufacturer, and from Leroy Sommer I've got 66 different motors in there, and there's all sorts of different manufacturers in there from the library. We can view or browse the library towards the end of the webinar. So I'll choose this motor, which is my 4-pole, and as soon as I select this motor, you can notice that these symbols have just turned green. So I'll select, hit OK, OK, and all my manufacturer part number, including all the details, have just appeared on the screen. And you notice this L4 location, which is the location of the motor, also appears on the drawings. So it physically, when you're giving this to a production guy, he knows where this motor is in your project. So L4 location, that's what I was referring to. So now for contactor, I'll just copy and paste this contactor on the line. Then you notice again it'll create the space automatically for itself. All I'll do, I'll just cross-reference this contactor to the contactor that I want it to be cross-referenced. So K4 associated to K4, and all done. Let's insert, now I'll insert some terminals on terminal strip X1. You can notice on your screen. So on terminal strip X1, I've got some existing terminals from number 1 all the way up to number 16, where my cursor is right now. So the next available, so the next terminal should be from 17, and you notice it'll do. So what I'll do, I'll just click on insert terminal. There's a dedicated tool for inserting terminals in there, and draw a line. And all I need to do is just pick up my right terminal strip X1 in that case, and it knows the next available terminals on that terminal strip X1 is number 17. So hit OK. Now the next steps are not necessary to do, but I'll show you what I'm doing as a part of a cabling management of your project. So right click on the terminal and edit the terminal strip. So define the terminals and make sure you define what is connected to these terminals that you've just created on these wires. So I'll shift select these terminals and assign the part that will be connecting. So from the wires, I've got different manufacturers in there. So alone from Wego, if I just select this manufacturer, I've got 7,863 different types of wires in the library. Okay, so what I will do, I'll choose my wire here, for example, this one, hit select, okay, and I've got for my protection wire, I'll choose a different type of wire. Okay. Now considering my motor is a bit too far from the power supply, so I need to assign, or I want to assign, a cable core to these wires. So how I'll do, I'll shift select all these wires, associate cable cores, and this will bring me into the cable management or associate cable core window. So if I just maximize it, I can create a new cable core on the fly, and or you could use one of the existing cables if they are free and not being used. So if you expand this W9, it's in bold color, which is indicating me that it is already being used, and these are the origin and destination of the wires inside W9 cable. Alright, W10 is available, so I can use this one. Shift select these wires inside the cable, shift select the wires that I need to use. Sorry, press the wrong button. Shift select all the wires that I want to be associated, associate cable cores, hit OK. Now I've got W10. So now what I'll do, I'll for example, if I want to draw the terminal strip drawing, there's an automatic tool. I can just hit this draw terminal strip and hit OK, and within less than a second I've got my terminal strip drawing right here, which I'll show you on my screen right here. So now imagine doing this drawing manually, and that accurately takes a while. So now I've got very detailed terminal strip drawing done automatically for me with all the cable numbers, and inside the cable with all the wire tags and the terminal numbers and each component what it's connected to. So let's close this. I'm nearly done on my schematic. There's a couple of things I need to do. I need to create a circuit for my PLC, as I've talked when I was showing you my single line drawing, but I know that I've already created that circuit somewhere else. So let's just I'll show you how we can reuse the existing circuits from a different part of the drawing, so or from another drawings that you have already created. So for example, let me just open this drawing, and that's the circuit I need to reuse. So I can simply copy paste it there, but if I want that circuit to be available on the library for everyone else, so I can simply drag and drop it into the macros and name it appropriately, for example PLC power, and once it's in macro it'll be available to everyone working within the library. Now I can close this drawing. Going back to my drawing again, okay, all I need to do is drag and drop to this circuit to the location where I need to. So once I've dragged and dropped, all I need is to change, so make sure that the cross-reference is cross-reference to my single line drawing. I'll just make it to be Q6, assign, hit OK, and I want that transformer to be T1, not T3. So right click symbol properties and then put number 1 and assign it and hit OK. Now drawing is done. There's a couple of very important things missing on this drawing: wire numbering and go-to marks for these or loose-ended or open-ended wires. For example, I have no way of telling where these wires are going to or coming from. So there's a dedicated tool which is manage origin and destination arrows at the top. So I'll choose that tool and let's see what the screen I get. So it brings up the drawing that you have on the screen and the next drawing that it thinks that you should be connecting these wires to. But if you believe that these drawings are not correct or not the right one, or you want to connect to some other drawing within one project, so what you can do, you can just switch around the next or previous drawings within one drawing or within one project, sorry, and choose the one you need to. So at this stage it is correct. I'll just choose single insertion point, and what I'll do, I'll select this wire, for example a blue one, go to the next drawing, and as soon as I take my mouse to the next drawing, it will only allow me to connect to this blue wire, not to the green wire. So it is, you can't really make error there. You can't connect positive to the negative or negative to the positive. So it is very good in terms of error reduction of errors, and which is a quite common thing when you're working on a big projects where you have multiples of drawings. All right, again choose my green signal wire and connect this to green wire here and close. Now you can see I've got go-to marks on my drawing. If I right click, and it will take me to the exact location where it's going to. So click, and that's where it's coming to. And if I take you back, it said drawing 7 and line 1. So that's my line 1 and drawing 7. If I just zoom in a bit, I can see this is my drawing 7 right at the bottom. So let's close this. Now let's have a look for the wire numbering and what we need to do for the wire numbering. There's a dedicated tool which we will use now to do wire numbering. Again, it's not a manual process. So I'll click on process and hit this button called number new wires and click yes. And very quickly you'll notice all the wire numbers are on the screen and done. Again, if you have your own standards for wire numbering that it's wire numbering are fully customizable. You can have whatever suffix and prefix that you want, alphanumerical or purely numerical wire numbering can be done in SolidWorks Electrical. It's totally customizable as per your requirement. So let's zoom out and have a look at some of the reports available, automatic reports available within SolidWorks Electrical. If I just click on project and the reports of that project. So I've chosen few reports to be displayed. So list of cables, list of cable cores, bill of materials, automatically generated from the drawing, list of cable tags, and drawing list. All are done automatically, and you can always add more reports in there if you need to. For example, all these reports, if I zoom it, make it bigger, so all these reports are available and they are fully customizable to as per your requirements. You can modify it and make it suitable to your needs. So let's just close it, and we've done the drawing, and let's have a look some of the PLC drawings, how the PLC drawings are represented in SolidWorks Electrical. So if I open this PLC drawing, so that's my PLC drawing, and that's how PLC drawing looks like. That we can get into details individually or personally. I'll discuss. If you guys are doing too much PLC drawing, then the PLC management tool, it's a very powerful tool, and we can do a lot of different things on PLCs very quickly. So but just to show you, that's how PLC drawings look like within SolidWorks Electrical, and there is a dedicated tool to modify these IOs of the PLC. For example, edit PLC, and you can do multiple different things in there. Alright, so now let's go to SolidWorks Electrical 3D and see what we can do in terms of routing of the cables and wires and inserting some electrical components. So within enclosure, you can notice that you're noticing that some of the components are already on the enclosure and some of the components are not in the enclosure on the bottom two DIN rails. So what I'll do, first thing, I'll insert some terminals on the chassis of this enclosure. So terminal strip X1 and insert terminals. And because you're working within SolidWorks 3D environment, you have access to all the smartness of SolidWorks itself. So for example, smart components is one of the features that I'm utilizing right now. When I take this terminal onto the DIN rail, it snaps onto the DIN rail automatically. So just drop it in there, and it's asking me which way do I want to go, right or left, and do I want any spacing between each terminal. So I'll say no spacing, and I want to go towards right, and press that tick button, and very quickly it's looking at the mating points on the terminals and on the DIN rail, and DIN rails are inserted from the built-in library of SolidWorks Electrical 3D. So alright, I've got terminals on my screen or within my enclosure. Now if you've got too many components, sometimes it can be confusing as a mechanical engineer to read all these electrical parts. So you can hide all the already inserted components in the enclosure by taking this box. So if I just now I've only got a few components left to be inserted. So shift transformer and right click and insert these electrical components on my drawing. So I'll just bring transformer in the middle for orientation, no other reason. Hit OK, and again it's asking me to drop my first component on the DIN rail, which I will drop it right now, and it'll ask me again, do I want any spacing between each component. This time I'll choose 12 mil. There's a transformer in there, so I'll just allow a bit of a spacing for the heat, and again I want it to go towards the right hand side. So you can notice very quickly what it's doing is just placing all the components. Alright, so I've got all the electrical components in there now. So if I just refresh it and just see if I've already inserted all the components, and there are no new ones. You can see there are none left in terms of component. There are a couple of terminal strips left, but I don't want to insert at this stage. Alright, so let's change the view and go to my motor view and have a look. On this motor, if you remember, we've already chosen a manufacturer part at 2D schematic level, and there is a 3D part associated to that manufacturer. So what I'll do, I'll right click, shift select, and associate that manufacturer part to this 3D model on my within my project. So now it's associated. So this will come to the routing, and let's just go to my enclosure. All right. So within my enclosure, there's multiple commands. I can either route cables, wires, and route harness. There's different commands to route each different thing. So first thing, what I'll do, I'll route wires, and I'll leave everything as it is, and I want all components in the enclosure to be routed, and I'll make the spacing between each wire to be 1 millimeter. So hit OK. Now very quickly you'll notice what it's doing right now. It's looking at all the schematics, that we have created in SolidWorks Electrical, and utilizing and leveraging a lot of data from there, and reading all the connection points of each device and all this, and creating a connection, creating a route for all the wires in that enclosure. Also looking at the cable management trays, conduits that we've got in the enclosure, and reading the path, predefined path for the wires. There's a segregation manager in SolidWorks Electrical 3D. So if you've got a high power and low power, for example, in one enclosure, and you want them to be segregated right hand side and left hand side, you can quite easily do that with using this segregation manager. So you can segregate your control wires and everything. So for example, now you can see very quickly I've got all the drawings on my screen, all the wires routed on my screen within this enclosure. So that's done. So the next part of the routing will route the motor, and see how that goes. So this time I'll click on route cables, not route wires, because I want solid cable, and so I'll choose SolidWorks solid route, not 3D sketch, and instead of all components I'll choose motor. So all done nearly. So all you need to do is just hit OK, and very quickly again it's following the same process as it was for enclosure. Alright, so very shortly you'll see the cable on the screen. There you go. So the cable is routed on this from this motor all the way up to enclosure. If I just zoom out so I can show you what it is, zoom to selection, all the way up to, if you're wondering how it found its path all the way up to, there's a sketch which was done for the enclosure, and all the conduits had the predefined path in to follow. So it looked at all these conduits and it knew it calculated the path to follow from the motor all the way up to electrical enclosure. All right, now we'll just look at the motor, some of the reports. So if I just, you get an access, or you can view all the same reports in electrical 3D environment, as well as the same reports as you get to see in 2D environment. So I've only routed one cable, and you see I've got the length in that report of that cable calculated based on the routing that we have done. Okay, now we just add one more report in there, for example, wire line type. Hit OK, and on this one I've got all the lengths of each wire in the enclosure with all the origin and destination marks, and all the color codes of each wire, and with the exact length which is calculated of all the wires that I have routed within enclosure. So let's close this, and we're nearly done. I'll just show you how would you create. There's two ways of creating 2D drawing of your enclosure. If you already have a 3D drawing of your enclosure, you may as well do it from the 3D to 2D. If you don't have or if you're only using electrical 2D, then you have your own tool set to create general layout drawings or enclosure drawings within electrical 2D without even using 3D. So this stage I'll just use or draw a 2D drawing from the 3D cabinet. So we'll just do that quickly. All right. So that enclosure and the bill of material of that enclosure on my screen, I can resize it accordingly so that it fits on my with my title block and everything. Now if you notice, I don't have some of the marks appearing on the component that I've recently inserted. So I'll click on SolidWorks Electrical, create marks, okay, and very quickly you notice that it'll create marks. So they ask me to on all the newly inserted components. So that's done. Now if I want to show the wires on this 2D drawing as well, so I can quite easily do that. All I need to do, shift select the path, because I didn't route them as a solid, so, and that's the way of showing all the wires on your 2D drawing. So now I've got that. If you want to create a 2D drawing of this view of your enclosure, all you need to do is a create project drawing, and then it will populate that drawing in your project document tree with all the title blocks and everything. All right, that's done. So now we've done all these things as a part of a demo all the way up to routing. I'll show you how this drawing would look like in terms of that. So we'll come back to that in a second. Let's just see in 2D. So for example, if we are, and that's a drawing that was, I cannot at the moment still. All right. So if I click on here, and that's a drawing that it just published. That's with a 2D view of the electrical enclosure and the bill of material on the front page as well. Alright, now let's come to the data management. How do you manage, once you've done all the drawings, how do you get them out of this software and to send it to the production guy or to somebody else to work on these drawings? There's an import export tool, so you click on there. There's multiple ways you can share it with your colleagues and do that. For example, if you want to send someone in these drawings in editable format, so you click them as export DWG files, and you can choose DWG or DXF and export all these files in either of these format. Export PDF, which we will do right now, and export components tree. These PDFs are the navigatable PDFs, and you know what I mean by that once I'll have. And again, you can export all these reports as an Excel file as well. So first thing, we'll export them as a PDF. So let's just do that. Webinar, name 1, save, and I want all of them to be. You can choose which drawings you want in one PDF file. So I want all. So all I'll do, I'll just hit print PDF button, and while it's printing, we'll get to that location where it's printing. So webinar. And alright, so that's done, and I'll show you what I mean by navigatable. So that's the drawing with my cover page from the project with all the reports that I chose. That's my overall 2D picture, and that's my single line block diagram, and I'll show you what I mean by. So if I click on this M5 motor, it'll take me exactly where it is in the multi-line schematic. If I click on contactor K6, for example, here, it'll take me to the drawing, within the control or PLC drawing where that contactor is. And there's multiple. If I can browse them like this, or if I click here, this will take me to the document viewer and components. So within my main electrical enclosure on chassis, I've got all these different components, Q6. So if I've got, for example, contactor K1, within contactor I've got contactor relay, I've got relay coil. So there you go. As soon as I click here, this will bring me to the contactor 1. So if I click on the drawing of this K1, there you go. It brings me back onto the single line drawing and show me where that coil is connected. So if I zoom out, and one more thing, not only just the components are navigatable, also the go-to marks of the wire. So if I zoom in and click on this mark, which is telling me this is going to drawing 7 in line 1, it'll take me to directly, and that's a PDF we're working in, not into anything else. So just a smart PDF that it prints out. Okay. Now the last bit, as I promised, we'll look into the revisioning management, how you can do revision. There's multi-levels of revision. You can either do revision at the project level by right-clicking and revision, and that's the revision management screen. So you can validate this one, and then just go yes. And after that, once it's verified, all the new changes will be done on the new revision. So hit OK, and it fills up your title block and everything automatically. And once you've done that, it knows that you've already exported that to PDF once, so it's asking you, do you want this to be exported to PDF file? So I'll just cancel at this stage. And again, you can do your revisioning at drawing levels. So your project may be at revision 6, but some of the drawings inside that project may still be at revision 1 or 2. So you can do revision at the drawing level as well. So all right. So you've seen how we can do the revisions here. There's a built-in tool. We can export all the files to PDM by just simply clicking this PDM button. If you've got a vault system setup, so I'll show you, I've already exported that before without wasting too much of a time. So let's just go there into my vault. It creates a folder automatically, webinar, and inside the folder it populates all the files, such as, for example, same PDFs, and all the reports in Excel file are here. For example, if I just open my bill of material report, all these reports are exported as a Excel file, and they all each manufacturer have a separate tab in there with all the marks, and the different reports comes in a Excel file. All right, and all the drawings are exported in a PDF. Not PDF, sorry, DWG format. So again, these are the editable formats. All right. So let's just get back to the presentation where we have left. So we've covered all these steps. We saw how we can reduce errors and cost by using planning and layout tools in 2D and 3D. Design schematic. We've seen how we can reuse existing drawings and use some of the built-in automated tools, such as creating automatically terminal strip drawings, producing reports automatically, and this will reduce the design time, hence faster time to the market for your products. Reduce material wastage by producing accurate bill of material. It's a single unified or synchronized bill of material of your mechanical and electrical parts, so you're not ordering one part twice or not ordering the part at all. So, and again, data control and security. So you've seen how we can do revisioning management, also how it works with PDM or EPDM software as well for your document management. So far we've done the demo. That was the demo basically, and we'll just look into some of the product offering again. We've seen that SolidWorks Electrical schematic, what it can be used, single line block diagrams, multi-line drawings, single and your cabinet layouts, control drawings, and also for your hydraulic and pneumatic it has a dedicated library. So if I switch it back to my electrical, I'll show you the dedicated library. So in my library, symbol manager, so if I just click on pneumatics and hydraulics, alone in this category I've got nearly 500, which is 465 to be precise, symbols in the library that I can use and modify if I need to. And within that it's got subcategories of actuators, accumulators, connection and joints, cylinders, and all sorts of different symbols available for pneumatic and hydraulic. All right. We've seen what we can do in electrical 3D, how we can do the routing, and there's much more to that we only have short time for webinars. So, and there's a bi-directional link between 2D and 3D. So 2D SolidWorks Electrical 2D is a standalone product. You do not require anything to run SolidWorks Electrical 2D. not even SolidWorks, but to run SolidWorks Electrical 3D, you require SolidWorks Electrical 2D and SolidWorks because it runs inside SolidWorks. And there is a professional package. You can buy both softwares as one license, and to run professionally you do require SolidWorks because it runs inside SolidWorks. Okay, just to recap, in Electrical 2D what we can do: blueprint of a system, for example, just a general overview design, right? And single line drawing, maybe a simple drawing or single line in that single line drawing may represent a harness or multiple wires, or because a single line is representing a cable in single line environment. Multi-line schematic, traditional multi-line schematics can be done. Electrical symbols are in the library, so you use them from the library. You can modify them as per your requirement and customize them. Each electrical connection is represented by discrete connection. As you notice, it creates the connection nodes automatically on the drawing. And again, very big library of the PLC in there as well. You can draw PLC drawings very quickly and neatly. And as you've also seen, you can do hydraulics and pneumatic schematics in that. And the benefit of doing everything in one package, the cross-referencing between all the drawings are there, so you're not hunting between one drawing to other drawing and manually finding out the product. You can simply use the right click and go to commands and go to the different drawings within one project. Cabinet layouts also can be done in purely 2D, SolidWorks Electrical 2D, without even needing SolidWorks 3D. We've seen what we can do in SolidWorks Electrical 3D. It utilizes SolidWorks Electrical technology, fully bi-directional 3D CAD integration. I'll try to skip, as I've already covered most of these parts in previous slide. Harness design is also possible in electrical. So what it does, for example, you create this similar type of drawing, what you can see on the screen in SolidWorks Electrical 2D. Then you do it at multi-line level, and you do it, for example, in position 3D development, such as this, what you can see on the screen. Wire assembly drawings, again, possible in SolidWorks Electrical. So it's many different applications can be done, or many different types of drawings.